The fourth parent function that we're going to be looking at today is y equals x to the third. And if we are setting up an xy chart to get our first few points, if I plug -1 in for x, -1 to the third power is a -1. If I plug in 0, 0 to the third power is 0. If I plug in 1, 1 to the third power is 1. And just to get an idea of the shape as we go out, if we plug in 2 for x, 2 to the third is 8. So you notice it immediately increases. So if we look at the shape here, we have our central point at 0, 0. We've got a point at -1, 1, a point at 1, 1, and we have our next point, just to give us an idea here, is at 2, 8. Okay, and then you can imagine that it's going to work in the same way in the negative direction. So our shape is going to look kind of like a snake-like curve, centered at 0, 0, and our points are symmetric about the axis. Now, if we want to look at just our general form, if we are thinking stretch and translations that we're going to cover in Chapter 8, we would write our general form as y equals a times x minus h quantity to the third plus k. And as you'll see in our further sections, the a value is going to be our stretch, h is going to be the x-coordinate of our central point, and k is going to be the y value of our central point. So that covers x cubed. Our next parent is y equals 1 over x. Let's do that in black. And same idea, we're going to set up a xy chart to get a few points. If I plug in -1 for x, 1 divided by -1 is -1. If I plug in a 0 for x, 1 divided by 0 is undefined, which just tells us we're going to have an asymptote at that point. Then we plug in 1 for x, 1 divided by 1 is 1. Okay, so that gives us a little bit of a basis for us to draw in our parent shape. So like I said, we're going to have in our parent an asymptote at an x value of 0, and we are also going to have an asymptote at a y value of 0, and that's because there's nothing we can divide 1 by to get 0. And then we can draw in our additional points that we found in our xy table, 1, 1, and -1, -1. And our shapes are going to kind of hug the asymptotes on either side. So they're going to get infinitely close to those asymptotes but never touch them. Now our general form of that parent is going to be y equals a over x minus h plus k. Now, a in this form, again, is our stretch, our vertical stretch. H is the x-coordinate of our central point, and k is the y-coordinate of our central point. And in this parent, there's not actually a point at the center of our graph, but rather that's where our two asymptotes meet. Moving on to our last function, we've got y equals b to the x. And b can be any value, And we're going to look at b generally, and then we're going to plug in a value for b. It doesn't matter what it is, but we're just going to look at 2 to the x. Okay. In our general form here, if we plug in a negative 1, b to the negative first is 1 over b, because a negative exponent flips to the bottom. B to the first is b, and I skipped 0 there, so b to the 0 is 1. So in the case of b being 2, 2 to the negative 1 is 1 over 2, which is a half. 2 to the 0 is 1. Anything to the power of 0 is 1. And 2 to the first is our b value, 2. So that allows us to draw in our parent shape here for y equals 2 to the x. We've got negative 1, 1 half, 0, 1, and 1, 2. Now, there's no exponent that could give us a y value of 0, so we've got a horizontal asymptote, and the shape of our graph is an exponential graph. Now, even though this equation looks a little bit different, the general form works the same exact way. We've got y equals b with our a stretch out front to the x minus h plus k. Or if we're talking about 2 to the x, that would be a times 2 to the x minus h plus k.